Good morning, fancy meat computers. How is it today? How is it on this very, very foggy November morning? It was so foggy this morning, couldn't see to the end of the street. Amazing. How is everybody? Pretty good? Decent? Okay, good. Good. Anybody got some chiptune recommendations? Since, normally I waste the first 3 or 4 minutes waiting for people to show up for these things. Anybody listen to chiptune recreationally besides me? Only when I'm selecting music for a game. Well, there you go. Super Mario Brothers original. Yeah, original soundtrack. Yeah. That's pretty good. Yep. I dig it. Mega Man 2 has a good soundtrack. Pinball Dreams. Ah, there we go. Oh, and you can't go wrong with any of the Fallen Brothers. Like, go give a listen to Tim Fallen, some of his work. He did like a lot of out of the way obscure North American titles. Most notably Silver Surfer, but also Pictionary on the NES, and like Pictionary has way too good a soundtrack for what it is. Another good one on the NES is Castlevania 3, but you have to get the Japanese version because it had 2 extra sound channels, and the difference is just amazing. Yes! Hey, doctor. I am a doctor. Is this a question, or are you just saying hey? Okay, I think he's just saying hey. Hey. All right. So, so let's continue on from where we left off, shall we? We were just dipping our toes into dipping our toes into classes. Let me just mute myself. Bloody Tears is an extremely good track, but I see your Bloody Tears and I raise you Mad Forest from the Castlevania 3 track. Or Forest of Madness, one of the two of those. I gotta stream some League of Legends. I would have to be able to play League of Legends first. I mean, I could totally stream you guys some Transport Tycoon Deluxe, Open Transport Tycoon Deluxe. I could totally do that. If y'all want to see some Mad Train action. Anyway, not streaming the video game. We're going to learn the stuff. We're going to learn the learning stuff. Okay, here we go. So last time we were sort of getting into this example of how one might go about using classes to create customized data types. We were creating a formalization of the convention used to sort of illustrate this large complex of character interrelationships in a popular fantasy novel series. I could even get like a conductor's hat for the stream. That would be awesome. So this, in general, right? Classes are a way of bundling together data with the operations that we apply to that data, right? So, in order to define which data gets packaged up into a class, the way that we are choosing to do this in this class, although there are other ways of doing it, is to place them inside of the constructor definition. Whenever we have some field, some attribute, that is referential to self via dot syntax, that is to say it's self dot some name, or some variable name, right? This binds the variable to the class instance, not the method, right? So name, children, and spouse all belong to class, whereas if I put another one, say temp variable is equal to something else, that would be bound just to the method, right? So that's the purpose of self. It's going to be like a little bit confusing as we get into this. This stuff is rightly considered. This is like the this is the tentpole difficulty topic of the course. After this, the difficulty starts to sort of slide down a bit, so long as you understood this stuff. But classes are the most difficult concept that we have talked about so far. With the possible exclusion of recursion. Nah, I'd say that this is I'd say this is more confusing than recursion because there's more stuff to memorize. Like, more ways things work to memorize, I mean. So, fine. Good. A custom data type represents a person that automatically has spots for the properties we want. Custom data types are called classes. Every class is built from an existing data type or an existing class. So when you leave the inheritance brackets empty here, all classes in Python, they all implicitly inherit from object, which is the most general type of thing. And all that does is like include like your most basic definitions, like what happens when you print it and stuff like that. We have to define a template for a custom data type. This template gives us how to initialize it and what operations are permitted over it. Then we can create instances of the class. Each instance is called an object. So in this case, Nick is an object. If I, if I wanted to create a new person object, I might go about it like this. And then classes are mutable data structures, so we can use them as references to themselves. So ali.spouse equals Nick, and nick.spouse equals ali. Right? Objectification. Ha! Oh my gosh. Okay, there's a that reminds me of a comic in another class. Which I'm not going to bring up right now. We have to keep going. So, good. So that's good so far as it goes. One of the big advantages of doing things with classes is that you can update the class, and this updates all instances of the class without having to go in and manually change everything. So, for example, with these data structures, let's say just for the sake of argument, you wanted to add another field for, I don't know, grandparents or something, right? Something to specify grandparents. If you were doing things like this, you would have to add a new field to every single one of these, and it would be long and time-consuming and tedious, especially if you have, maybe as many person objects as would be kept in something like, one of these online test your DNA sites, right? Or like one of these online websites that creepily ask you about your entire family history, right? In the same way that keeping a bunch of statements and subroutines in a function allows you to quickly and easily fix bugs, find problems, add functionality by just modifying the function, classes provide you the same type of abstraction. You don't have to fix everywhere the class is used, you just have to fix the class itself. This is good. So, to define a new class, the syntax is class, my class name, what it's built on, or you might say derived class, base class. We say that my class name extends what it's built on. We can always extend the built-in starting point object, and if you do not include anything in the braces, object is assumed by default. Next, we have to define a template for our custom data type. This specifies how you initialize it and what operations you can perform over it. This is the purpose of the init method. Init, with 2 underscores on either side, is a special function called an initializer. In more sane programming languages, we would call this a constructor. It is called whenever we try to make a new instance of this class. So anytime you create a new object of the class, so for example, in this line right here, Harry is equal to person with the open close braces, if you take the name of the class and call it like it's a function, that creates a new instance of the object, or that creates a new instance of the class, which is called an object, right? And then assigns a reference to that new object to whatever the assignment is assigning to, right? When you create the object, init is run. All right? Make sense so far? Give me a thumbs up if you're following. Inside the initializer, we can define instance variables that are associated with each instance of the class. Instance variables are sometimes called members or properties or attributes. In general, I like I tend to default to C++ nomenclature for these types of things because I think C++ does this very well. And I think that C++ was invented early enough that, like, many other languages should have used C++'s naming conventions, but they, they didn't because they wanted to be different. But in C++, this guy right here is called the base class. This is called the derived class, right? This is called a constructor, which makes sense because it constructs it, right? And these individual variables are called member variables because they are members of the class. Do you not need to pass the name as a parameter in init? So I am doing that here, right? I don't have to. Any arguments you specify inside of the method name, inside of the list of method arguments, these are things you can use to initialize your class with. Makes it parameterizable at the point of instantiation. If you remove that, if you like get rid of this bit and just set a default value here, you can always set the value of the member variables later on in the same way that I'm setting children and spouse. But yeah, so this is kind of like a thing you can do optionally, adding extra parameters here. Doesn't C++ also have destructors? Yes. And I'm sure Python does as well, actually. Let me just look that up quickly. Python destructor. So the destructor method is del with underscores on either side. However, the first hit on Google is telling me in Python, destructors are not needed as much as in C++ because Python has a garbage collector that handles memory management automatically. Yes. It is called, so the del method is known as the destructor method in Python. It is called when all references to the object have been deleted, i.e. when an object is garbage collected. So there you go. Boom. Different instances of the same class will have independent instance variables, obviously. So I can, for example, here, print, Nick.spouse and Ali.spouse, and these will print different things. Python 3 topic 8.py. So you can see that while it's printing mostly the same thing, the two memory addresses that it's giving are different memory addresses. So these are different objects. But So you can see that the value held in both of these guys is independent, right? And I could do stuff like, you know, ally.spouse.name, nick.spouse.name. Nick's spouse's name is. There you go. Right? Make sense? When you set the spouse of Allie to be the object Nick, does that set the spouse to be a copy, or does it point to the original data structure? Ha! Excellent question. It points to the original data structure. So, for example, if after that line I was to say something like nick.name is equal to my full name, you'll see that the copy, like the version of my name that's accessible through ally.spouse.name has been updated, even though I'm updating it through nick.name. So this is an aliasing. This is definitely an aliasing situation. By the way, for other people watching, YouTube will tell you that you are live, even if you are a good bit behind in the live stream. Yes, that's an excellent tip. You might be behind the 8-ball, like you might not be synced up with the lecture, so you can set the playback speed to faster than time is passing, and that'll allow you to catch up to where we are in the lecture. Cue like 3 minutes from now when everybody catches up to the lecture. Good. There we go. Different instances. Yes, good. So we can add functions to a class other than the initializer. This is kind of the whole point. If it weren't for the fact that we could add additional functions, all we would be doing is bundling a bunch of variables together. So let's write a function. Define fidelity checker. Takes self. Yes, just self. So let's say we want to return whether self.spouse is equal to self.spouse.spouse. All right. So what this does, right? It checks to see. Oh no, this isn't gonna work. Let me think here for a second. What we want is self is equal to self.spouse.spouse. I think so. Right, because like I want my spouse's spouse to be me. Yeah. So print, is there funny business going on? Then not nick.fidelity checker. Oop. There we go. Whereas, if I were to say, for example, Newman is another person, and his name is Newman the Home Wrecker. And let's just say, for the sake of argument, that Ali.spouse was set to Newman, the homewrecker, then there would be funny business going on. Right? Except this would create an error if a different data type was set as the spouse, such as a string. Well, yes, but this is Python, so however you use it, that's how it's supposed to be used, right? Well, no, actually, I think it would work if it were like consistent strings, right? But well, no, you'd need self.name. You'd need to do that or something like that. Yeah. Yeah. Yeah, if you put self.name and spouse.spouse.name, then that's another way of doing it. Yeah, you're right. What I'm doing with this particular one is I'm checking to see if the objects are the same object. You know, if I did self.name.name, right, and I had imposter Nick, whose name was also Nick, right? And then I did the fidelity checker. It would, oh, wait, I didn't set this to imposter Nick. See? In that case, my wife could be married to my imposter, and because it's only checking to make sure the name is the same, and since the imposter has my name, then it looks like there's no funny business going on when actually there is. Right? That is kind of sus. So there you go. Does that make sense? Hopefully I haven't just confused people. Anyway, the example that's given in the slides is just a sort of Boolean check to see if the subject is married or not. Doesn't matter to whom. Oh, question. What does the self in init mean? Would we need to write anything when defining an object if there is no nom? Well, or name. Don't tie yourself to that as a name for things, right? It can be named anything. So in Python, the first argument is always, always, always a reference to the object that's being called, right? Or to the object on which the method is being called. So, for example, if I take this guy right here, right? What that actually gets called as, this is equivalent to person.fidelity checker on Nick. I don't understand why name doesn't work. So let me just do this and then come back to that, right? So this is actually also completely valid syntax, right? So I can actually swap this in and use it this way as well. And everything is exactly the same, right? You can access these methods either directly through the class definition, in which case you have to supply the object you're applying it to satisfy self, or you supply the object. You don't have to specify the class because the object knows what class it's in, and then you don't have to specify the first argument because it's being specified here. This is one of the ways in which Python doesn't make any sense, in my opinion. But that's the way that you can do things. So, I don't understand why name doesn't work. So, just to recap, I'm... Sorry, I'm teaching a class. So... What was I saying? Before I was so rudely interrupted. Completely broke my flow. Yes! So in this example, what I'm doing is I've got 3 person objects, right? I've got Nick, Imposter Nick, and Allie. Since the fidelity checker method is only checking against self.name, right? If I've got 2 objects, if I've got 2 person objects that have the same name, right? Then, yeah. If I've got 2 person objects that have the same name, then the way that this fidelity checker works is it takes the name of the object, the name of the person object that the method is being called on, right? It then finds out who the spouse is. Then it finds out who the spouse, like, who is specified as the spouse of my spouse and what is their name. And if that's the same as my name, it assumes no funny business is going on, right? But if 2 people have the same name, right, then my spouse could be married to my imposter who has the same name, but this check would not tell me that there was any funny business going on. What if you did Nick fidelity checker Allie? That's a good question. Let's do that. You're going to get an error, but we'll do it anyway. Nick.fidelity checker Allie. Fidelity checker takes 1 positional argument, but 2 were given, right? Now, there is going to be a way of doing that. What you can do, I think you can just overload it. I think this isn't something in the slides, but I think it'll work. Return self.name is equal to other.spouse.name. I think that will also work. We'll see. Missing 1 positional argument. Ah, okay, so no, it doesn't. You can't just overload like that. Okay. So, we'll just say other is a thing with a default none, right? If other equals none, then we have the first version, else we have the second version. Return self.name is equal to other, self.spouse.spouse.name. There we go. And you can see that fidelity checker is still turning out the same result because we're still only testing the name. Python doesn't support overloads. As I find out. Oh, so Allie is passed as the second argument into the method. Well, if we, yeah, that's what it did. Yeah. Sounds, yeah? Yeah? Does this make sense? Give me a thumbs up if you guys are following this. So. Good. Good. Right. So let's move right along, shall we? I know that was a bit of a complicated example, but I think that, like, that demonstrates, like, dot access somewhat better than, you know, what was on the slide, shall we say. So, everything in Python is an object. Everything. So, if we ask for the type of an integer literal, oh, it is of class integer. If we ask for the type of a function, class built-in function or method. And of course, if we ask for the type of our person objects here, it's going to return main.person. The reason it says main.person is because we are defining these classes inside of main. So that's like a locational specifier. The class definition defines attributes, properties, variables, members, and methods that are common among all instances of that class. Attributes of a class or an object are referenced using dot notation, and we've seen a number of examples of this so far. Here is another example. So let's do a live code session. We're going to do points in two-dimensional Euclidean space. Points in two-dimensional Euclidean space. Euclidean space. Do 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 do. Euclid. Euclid. So, live code. Everybody get your keyboards. Def. Point. Inherits from object, which is to say nothing. Almost nothing. Define the initializer, or the constructor. We'll take self, an initial x and an initial y position. And we shall say self.x is equal to x naught. Self.y is equal to y naught. Because why not? Wah, wah. Oh, yeah, pardon me. Class, thank you. Thank you, the chat. I don't make mistakes. That's fake news. Yeah. Sorry about that, folks. So, we've got a couple of things that we can do to points. Yeah. Number one, we can translate them. So we can take some kind of delta of x and y, and we can add that to it. So let's define a translate function. Takes self delta x and delta y. Self.x plus equals delta x. Self.y plus equals delta y. Easy enough. I think JavaScript calls func to describe objects, which is weird. Yes, JavaScript is kind of weird. You should use TypeScript instead. This is what I've been hearing, is that everybody who uses JavaScript should be actually using TypeScript. Because it has a type system that's functional. So, def scale. Another thing we can do with points. Set some scalar factor. Let's call it s. And move scale everything relative to the origin. So self.x times equals s self.y times equals y, s. Static typing all the way. Right? Yeah. Thank you. Thank you, Tony and Village. Turing complete type system. Ha! Perfect. So, If you want to know, if you want even the slightest, vaguest impression of how a type system can be Turing complete, take 3MI3 when I'm teaching it. Finally, let's do something pretty standard, which is the distance between 2 points in two-dimensional Euclidean space. So define method distance 2. We shall specify self and other. Return self.x minus other.x squared plus self.y minus other.y squared to the power of 0.5, which is Python shorthand for the square root function. Good. So now we can say A is a point. 4 and 7. We can say B is a point. 8 and 2. We can say B dot translate -3, 8. We can say print A dot distance to B. There you go. So the distance between A and B is this much. Very good. So, good. Methods are called using dot notation. The first parameter, named self by convention, is bound to the object which the method is being called on. p.move11 is the equivalent of point.move p11. The init method is implicitly called when the object is created, etc., etc. Question. So because we don't have to declare types, other can literally be any other object with the attribute called x. Yep. Yep. It's not constrained. Anything with an x coordinate can be used. You know all of that complaining I did about Python's type system, like last time? Well, are you beginning to see why I hate Python so much? Like just a little bit, just a little bit, just a little bit. Ooh, just a little bit. Python's not very good. Python is not very good. Yeah. Like, I really can't, I just, like, I cannot overstate how frigging annoying it is to have to reference all of your member variables, all of your member variables that aren't local to your methods, having to reference them through self. It's like, it's so annoying. This is what a sane language does, folks. It's like, you say, I have a public variable x, you know, I public int x, right? And then you just refer to it as x everywhere, right? You don't have to include the self. But because Python is Python, and Python is the worst, you have to include self everywhere. It's just like how, you know, in a sane language, you can just say, I have a private int y, right? And then y is just private. Not only do you not have to include self dot, you also don't have to include the 2 underscores, which indicate private membership in Python, because in Python you have to include those every single time you use y. And if you forget it, Python will conveniently ignore the fact that you have a private member that's got the same name, and it will create a new public member with the same name and use that instead. I hate Python. I wish I was teaching you something sane, but, you know. Python's easy to learn, though, guys. Trust us. It's totally true. Anyway. So let's talk about printing. By default, print outputs an internal representation, usually a memory address. Not usually, it just prints out a memory address of the object. We can override this by providing a definition for the string method. How is this one of the most commonly used languages? I think it's a conspiracy. Personally, I think it's a conspiracy. Because, like, you know, about, like, 8 or 9 years ago, everybody decided to use Python, switch to Python all at once. I think, I don't know, maybe all the universities are getting kickbacks from the Python Foundation or something. But, like, the reason that Python is taught in introductory programming courses is the theory is that students get tripped up on syntax, right? So a language with less restrictive syntax is easier to learn. You don't have to import anything. Like, you require, like, it's like they took all of the languages, decided how long the Hello World program was in that language, and then made their decision based on that. Because, like, in Python, Hello World is 1 line, right? In most languages, it's at least 4 lines, because you have to do some declaration for main, right? Like, that's like, you know, never mind the fact that Python syntax isn't actually less complicated, because everything's being loaded on indentation, rather than being loaded on curly braces. That's not actually less complex, you know? Sure, you don't have to include semicolons at the ends of lines, but was it really that big a deal to put semicolons at the ends of lines? Yeah, big Python. That's what it is. It's because you don't have to worry about typing. People find it annoying. See, the thing is, you do have to worry about typing, right? You do, if you're a good Python programmer, and you're not just like a hacking things together bedroom programmer, then yes, you do still have to think about typing. You're just not given any of the tools necessary to enforce it. It seems more popular in terms of people who aren't professional programmers. That's another one, yeah. There's a myth that Python is easier to learn. This means that people who are not, like, programmers proper have, like, adopted it. You see Python used a lot in, like, the science faculty, for instance. Is there a reason why point inherits from object? I searched it up, and it appears to be related to new style classes, but in 3.x, new style classes were made the default. Yeah, it's not really... Again, you can include it or not. It doesn't matter. Everything inherits from object. So, yeah. Anyway, I've had my little rant. So, overriding things with... we've seen this before, but if we print out one of these objects, what we get is main.pointObject at memory address. We can make this more useful. Let's say def string. This overloads string conversion for this class. Just take self return that plus self.x plus comma space plus concatenate self.y concatenate close brace. There we go. Oh, I need to string convert these as well. There we go. So now, instead of printing off this big pile of hot garbage, we get something that actually looks like coordinates. But we need to tell Python how to do that. It's necessary to tell Python what you expect a printed object to look like, right? Because it can't intuit this, right? Good. Are there any questions? Pardon me, sorry. May we see your cat? So what is string? String is the name for the default string conversion method. I'm overloading it so that it does something more useful. Can we see your cat? Let me just go see if there is a cat about. In which case, yes. The cats are hiding. They're under the bed or something. I can't find them, so ask me next week. Yep. Alright, I'm gonna log off here. Take it easy, folks. I'll see you next week, eh?